Hello and welcome to By Excellence Tutorials. In the previous two sessions, videos of course, we stressed into finding or arriving at these relationships so that we can use them into deriving velocity and acceleration in polar coordinate system. So in this video, we are going to derive velocity and acceleration. Without wasting time, we have the velocity of a particle in central force field, okay, given by velocity. Okay, let me use black. This velocity is given by the change in position with respect to time. This is how velocity is given. Now, from the first video, you're going to see that we found the position, vector position of a particle is given by the magnitude of the position multiplying by its unit direction or unit vector. So we substitute in this derivative with magnitude and unit vector. So we are going to have velocity being equal to like that. And then that is a bit of, this is a bit of calculus, okay, basic calculus, where when R is changing, the unit vector will remain constant. And when the unit vector is changing, R is going to remain constant. So what we have is unit vector in this case is constant and R is changing, plus R is constant and unit vector is changing. This is what we're going to have. So now we can differentiate that where we have velocity is going to be. So once we differentiate with respect to time, like we've been doing in the previous video, we're going to put a dot on top to show that it's been differentiated with respect to time. So what we have, we're going to have the unit vector and R dot here plus R multiplying by the unit vector with a dot that has been differentiated. So from the relationship, the first one, we are going to find what this R dot is representing that we have found. That's what we were doing in the previous video. So we substitute here. So we have R dot plus R dot and unit vector. So velocity, okay, velocity is given by this plus R theta dot and unit vector. So this is how you get the velocity, as simple as that. Okay, so this is a vector velocity. As simple as that in the polar coordinate system. So how do we get the acceleration? So we get acceleration from velocity. We know that acceleration is given by change in velocity with respect to time. And we have already found our velocity, which is this. Okay, dot, and then we have that. Okay, so this is, we can distribute the operator where we have change with respect to time, and then we have R dot plus, plus, so change Okay, so even here, when this velocity is changing, the condition is that when the other part is changing, the other part remains constant. So we are going to have a situation like this one, where we have where we have this is constant, and then we have that changing with respect to time, plus this is going to be constant now, and that will be changing with respect to time. Then we go to the next one. We have R changing, so these two are going to be constant and R is changing, plus the other one, theta dot, is changing, and what we are going to remain is constant is that the theta dot, plus which one is also changing now? The unit vector in rotation is changing, so we are going to have that. Okay, so it has been distributed. So we begin, and here we're going to have R dot and that with dot cap. Okay, we've differentiated, plus R cap. Okay, and then we have, this is differentiated twice, so we have two dots, and then we have plus. Here we have differentiated R, we are going to have R dot, theta dot, and R dot here. And then here we have differentiated theta dot, we are going to have two dots again, and then we have that cap. And then here we are going to have theta and theta dot. So we can now bring our relationships, these relationships, where there is, so here we substitute, and also here. So we are going to have the equation looking like R dot, theta dot, and theta cap, plus R like that, plus cap, and then this will also come the way it is, cap, and then plus, this is going to be not plus, it's going to be minus, because we have a minus there, and this is going to be minus R theta, and this one is theta that. So it's like we have that, may not confuse someone, we have that. Okay, so we continue manipulating, of which we are going to see that we have something common here, where we have this and that, they're same, so we can add them. So what we are going to have is plus 2R dot theta dot and cap, like that. Okay, and then we have plus R theta dot, and this is will be minus R, and then we have two theta dots, which is going to be squared, and then a unit direction, like that. So from here, we we group these now into according to their unit vectors. So where we have a unit vector R and R, we group, and also this with unit vector we group as well. And we are going to have, and we factor out, of course, minus R theta. We factor out that. Then we have plus. Here we are going to have R theta plus 2R theta. And this is your acceleration in central force field. This is how you get acceleration. Have you found this video to be helpful? Kindly subscribe to the YouTube channel and hit the notification bell so that you can get notified each time I upload a new video. And you can give it a like, you can share the video, and thank you for watching.